Identify the equation whose graph is symmetric with respect to the origin. Let's take a look at each one of these equations and think about what their graph would look like. For the first one, part A, y equals 4x to the third. So y equals x cubed is actually a basic graph that we want to be really familiar with. The shape, you can memorize this. The shape looks something like this. It has a little bit of a wiggle there in between. So this is a shape that we can memorize, y equals x cubed. If we put a number in front like the 4, that's going to vertically stretch it. So it's going to be the same overall shape, but it's going to be a little bit skinnier, maybe just a little bit closer to the y-axis. So this line here in red could be representative of 4x to the third. We're looking to see which graph is symmetric with respect to the origin. So origin symmetry means two things. It means that our graph reflects over the y-axis and it reflects over the x-axis. There's two reflections, and the order doesn't matter. So let's say that we look at this top part of the graph first. If you think about what that would look like if it reflects over the y-axis, imagine that now that curve is over here, and then it reflects over the x-axis, so it moves it down here. So sure enough, this is a result of those two reflections, and so it is symmetric with respect to the origin. So part A, we'll choose that for our answer choice. Now, if we look at some of the others, we can throw them out. So part B, this is just going to be a line. It's in the form of y equals mx plus b. It would have a slope of 5 and a y-intercept at 3. So it would end up looking something like this. And if we think about those two reflections over the y over the x, we see this is not going to work. Part C is actually a little different altogether because notice the x and the y are switched. If it was y equals 4x squared, this would be a parabola that has a vertical stretch, so it might look something like this. By switching the x and the y, that would actually turn our parabola shape sideways, making it look something like this. So this is actually x-axis symmetry, right? But it doesn't have that additional y-axis symmetry, so it's not symmetric with respect to the origin. And then this one has all sorts of things going on. We have y to the third power. If we cubed root both sides to get y by itself, it's just going to be pretty messy and complicated. And this is actually not even a type of graph that we commonly use or that we would need to be familiar with at all. So we can also eliminate that one.